Now we're going to take a look at how to solve systems of equations that have three variables. These three variables are generally going to be x, y, and z. So these are still linear equations, but they are in 3 dimensions. Now, we have ax plus by plus cz equals d is our standard form for a linear equation of 3 variables. Note that a, b, c, and d all have to be real numbers, and a, b, and c cannot all be 0. You can have 1 or 2 0 at the same time, but they can't all be 0 together. All right? So this is a linear equation in 3 variables, x, y, and z. A solution is going to be an ordered triple. So previously we had an ordered pair, and that is a point in 2 dimensions. We're now going to talk about an ordered triple, which is a point in 3 dimensions. It's written the same way as an ordered pair is, except now it has 2 commas and a z. So let's check to see if -1, -4, 5 is a solution of this system. Notice that in order for it to be a solution of the system, it has to be a solution for each and every equation. Also, notice that -1 is the x, -4 is the y, and 5 is the z. So we're going to start by plugging in -1, -4, 5 into the first equation. Don't forget to put your equal sign at the end. We get -1 plus 8 plus 15, which does come out to be 22. So this is a true statement, which means that -1, 4, 5 is the solution of the first equation. Let's test it in the second equation. I end up getting -2 plus 12 minus 5 equals 5. Well, -2 plus 12 is 10. 10 minus 5 is 5. So this also works and is therefore true. So I've checked it in 2 equations. I still need to check it in the third. So I'm going to plug it into the last equation, and I end up with -3 minus 4 minus 25, which comes out to be -32, exactly how we had hoped it would be. Okay, be careful. You'll notice that the negative didn't actually get typed. Good news is in the final answer, it was there. So since it is true for all 3 separate equations, we can say that it is a solution for our system. Now, how do we solve these types of equations? Well, the first thing you need to do is reduce the system to 2 equations with 2 variables. So basically, get rid of one of the letters. Then you're going to be able to solve what's left over, like we did in the previous section. Okay? So you're going to be able to use addition or substitution at that point. I'm going to tell you that addition or elimination is probably the most common of the methods for these. Once you know one variable, you can back substitute to find the next variable, and you can back substitute those to find the variable before that. Then you're going to check your answer in all of the equations. It is important to make sure that you check your answer, because sometimes you're going to get something that's real close to right, but doesn't actually work entirely. So let's go ahead and practice solving an equation, a system of equations. Okay, so here I am going to get rid of one of my letters. I'm going to get rid of z. Okay, so to get rid of z, I'm going to start by adding the first 2 equations together. And when I do that, my z's cancel, and I end up with 4x plus 6y equals 28. Now, I need to get rid of z with some other pairing. Okay, so I've already used 1 and 2 together, but I could then choose to eliminate z in 1 and 3 or 2 and 3. It's up to me. Now, personally, I'm going to use 1 and 3. So I'm going to get rid of z in the first and the third. So I'm going to multiply the first one through by 2, and that's what gives me 2x plus 8y minus 2z equals 40 that you have down here. I'm going to write my other equation down exactly the way I had it. And when I add down now, I get 4x plus 5y equals 24. So you see, I now have a system of equations with just x's and y's in it. So I'm going to solve what I have left. Probably I would say by addition is easiest. Because if you look at this, you're going to notice that the coefficients of x match. One's positive, or they're both positive, so we want them to be one positive, one negative. So I'm just going to multiply the second equation through by -1. Then I'll add my two equations together, and I end up with y equals 4. Now, once I know my y, I can find my other letters. Now, I'm going to start by finding my x, because that was the letter that was in these equations. Okay, so I'm going to find that that's probably the easier method. So I'm going to plug y equals 4 into 4x plus 6y equals 28. So that was one of the equations I had for my simplified system. And I get 4x plus 24 equals 28. I subtract 24 from both sides and divide by 4, and I get x equals 1. So notice that so far I have x equals 1 and y equals 4. So I know my answer is going to be 1, 4, something. To find that something, I'm going to plug 1 and 4 back into one of my original equations. I pick the first one. So I have 1 plus 16, which is 17, minus z equals 20. I subtract 17 from both sides, and I divide by -1, I get -3. So now I have the answer 1, 4, -3. At this point, I want you to pause the video and make sure that, notice first of all, we use this first equation to solve for my last variable. So I've already just used that. But make sure that it also works in the following two equations. Then come back here and we will continue on. So hopefully you've had a chance to do that checking, because first of all, we already knew it would check in the first one because we used that to solve for our z value. Okay, but when we checked it in the second one, we got 3 plus 8 minus 3, which does come out to be 8 equals to 8. And when we checked it in our third one, we ended up with 2 minus 12 minus 6, which came out to be -16, exactly how it was supposed to. So it definitely worked, which means we got to keep 1, 4, -3 as our final answer. So one of the things that we use this for most often is finding quadratic functions that go through 3 points. Because if I know 3 points on a parabola, I can guess and check answers to find a quadratic function, but that's not really a great method. So instead, we're going to use our system of equations method instead. So we're going to find the quadratic function in the format y equals ax squared plus bx plus c. That goes through the points 1, 4, 2, 1, and 3, 4. To do that, we're going to start by plugging each point in to the equation. So we'll plug in x, 1 for the x and 4 for the y. And that gives us 4 equals a plus b plus c. Then we're going to plug 2 in for the x and 1 for the y. That gives us 4a plus 2b plus c equals 1. Excuse me. Then we're going to plug in our last point. X is going to be plugged in for 3, and y is going to be plugged in for 4. And that simplifies down to 9a plus 3b plus c equals 4. Now we have a system of equations, and when we solve for a, b, and c, we're going to be able to plug those back into this formula to find the equation of the quadratic. So I'm going to set this up like a system. I want you to take a moment and try and decide how to get rid of one of the variables. Once you've gotten rid of one of the variables and you have a system of linear equations with 2 variables left over, press play on the video and we'll check it. All right, so I chose to get rid of c. To do that, I multiplied the second equation through by -1 and added it to the first equation. When I did that, I got -3a minus b equals 3. Then I did the same thing, okay, where I took the first equation and I multiplied the third equation through by -1, and I added down and I got -8a minus 2b equals 0. So that gave me a system of equations that looks like this. -3a minus b equals 3, and -8a minus 2b equals 0. Please solve this system for both a and b and come back here to check your answer. So, hopefully you were able to solve this. I used the addition method. I multiplied the first equation through by -2, and I kept the second equation. That allowed me to add down and cancel my b values. And I have with -2a equals -6. I divided both sides by -2, and I got a equals 3. I substituted that back in to one of my equations that was two variables. I used the -3a minus b equals 3. Okay, so I replaced a with 3, and I got -9 minus b equaled 3. I added 9 to both sides and divided by -1. That gave me b equals -12. So at this point, you should have had a equals 3 and b equals -12. Go ahead and solve for c and attempt to write your equation for the quadratic in standard form given that answer. Now, to solve for c, I used the first equation because I thought that was easiest. So I plugged in 3 for my a and -12 for my b. That gave me -9 plus c equaled 4, and I added 9 to both sides. That gave me c equals 13. Now that I know my a, my b, and my c, I can write my equation, which is y equals ax squared plus bx plus c, as y equals 3x squared minus 12x plus 13. Because all I did was replace my a with 3, my b with -12, and my c with 13. It's probably a good idea to go ahead and plug each point back into this to make sure that it works. So you plug in 1, make sure you get 4. You plug in 2, you make sure you get 1. You plug in 3, you make sure you get 4. But I want you to find the answer to this one right now. So read the question, solve it, and press play when you're done. So in this case, they want us to solve it, and I'm going to choose to use elimination method. Now, personally, I like getting rid of the z's, but in this particular problem, it's probably easier to actually get rid of the y's. So what I'm going to do is I'm going to say this first one times 2 becomes 12x minus 2y plus 4z equals -24. Okay? And first of all, as a note, you can do this with getting rid of the y's, the z's, or the x's. So if you got rid of another variable, it's fine as long as you come up with the same answer at the end and you showed your work in the middle. Okay? So I'm going to use this version, though, for both of the next pairings. So I'm going to first pair this with the second equation. And when I add down, I get 13x plus 3z equals -19. Okay, because you'll notice the two i's canceled. Then I'm going to pair the first one with the third one. Okay, and that's going to let me write 2x plus 2y minus 3z equals 8 underneath the same thing that we did, because my y's are still going to cancel that way. And that gives me 14x plus z equals -16. In order to solve this system, I am going to get rid of my z next, because I can copy down my 13x plus 3z equals -19, and I can multiply my other equation here by negative 3. Negative 3 times 14x comes out to be negative 42x. Negative 3 times z is negative 3z. And negative 3 times negative 16 is 48. When I add these together, I now have canceled out my z's. I end up with negative 29x equals 29. I divide both sides by negative 29, and x is coming out to be negative 1. Now, I need to find my other letters. So I'm going to plug my x back into one of the formulas that had just x and z. I'm going to plug it back in to this version because z is by itself. So I have 14 times negative 1 plus z equals negative 16. Negative 14 plus z is negative 16, but then I add my 14 to both sides, and I get that z equals negative 2. Now that I have my x and my z, I can solve for my y. To solve for y, I'm going to plug my x and my z back into one of the equations from the very beginning. I am leaning towards this one here because it seems to have the least amount of multiplication. So I'm going to have negative 1 plus 2y, and then minus negative 2 equals 5. Well, notice that minus negative 2 is the same thing as plus 2. So negative 1 plus 2, when I combine like terms, gives me positive 1. I subtract 1 from both sides. I divide by 2, and I get y equals 2. This means that my final answer is the point negative 1, negative 2, 2. Note that before you box it, you do still need to plug it in to the original equations to make sure it works for all of them. Okay? And I kind of ran out of space. But when I plug it in, I'm going to just kind of cram it over into the side here. So notice I used the purple equation that I circled there already to solve for my last variable. So I really just need to check in the first and the third. So when I plug in negative 1, negative 2, 2 to the top one, I get negative 6 plus 2 plus 4. Did I write that right? Oh, negative 2 for my z. You see, this is why we're checking. Plus negative 4. And, I see what happened. See, and again, this is why we check. My y is 2, my z is negative 2. I had those backwards. Okay? So we're going to try this again. And this is going to be a great example of why we check things. Yeah? Yeah? Okay. So I'm trying this again. I plug negative 1 in, I get negative 6. I plug in 2, I get minus 2. I plug in negative 2, I get minus 4. And I want to know, does that equal negative 12? It does come out to be negative 12. So now I know that I have it correct. But again, I'm going to still check it in my third equation as well, which I'm going to just do right here. When I plug in negative 1 to negative 2 to that, I get negative 2 plus 4 plus 6 equals 8. Well, 8 does equal 8. So now we can be sure that it works. So be careful, especially if you got rid of the y originally. That means you're going to have y as your last answer that you solve for at the very end. Then you want to make sure that you put things in the correct order. So it goes x, then y, then z. So I'm going to give you this graph, and I want you to find its equation using a system of equations. You're going to want to pick 3 points whose coordinates appear to be integers. So for example, I would not pick this point because that is definitely a fraction. But I like this one, and I like this one, and I like this one, and this one, and this one. So which ones you choose, you need to pick 3 of them, are up to you, but those are the ones that you can choose from. Come back here once you have that down and check your answer with me. So I've just picked the first 3 points. So I have 1, negative 6, and 3 would be the x value here, 3, 2, and 4, 3. Okay, so my equations are y, oh, I am so sorry, -6 equals a plus b plus c. And then we have 2 equals 9a plus 3b plus c. And then we have 3 equals 16a plus 4b plus c. Okay, so again, notice what I did was I plugged in 1, 3, and 4 for the x's, and -6, 2, and 3 for the y's. Now, in order to solve this, I'm going to get rid of the c first. So I'm going to multiply through this first one by -1. And that's going to be for both simplifications, because both of my other ones here have a positive c. So that makes it easier for me to just have the same thing for both. Now, when I add down here, I'm going to get 8 equals 8a plus 2b, and the c's canceled. And here I'm going to get 9 equals 15a plus 3b. Now, for me, I look at this and I say, I bet I can simplify this. This looks like I can simplify it anyway. So I'm going to divide this equation through by 2. And actually, I really can't write it that way. Let me write this properly. And divide this equation by 2. That gives me 4 equals 4a plus b. Now, then I'm also going to divide this other equation, but this one I'm going to divide by -3. That gives me -3 equals -5a minus b. So you can see that I divided through by the common piece for each, the greatest common factor. And for the second equation, I divided through by a negative, simply so my b's would now be opposite signs. When I add these together, I get 1 equals -a. So that tells me my a is -1. Since I know my a, I can find my b. So I'll just use this one right here. 4 equals -4 plus b. I add 4 to both sides. I get b equals 8. And then I'm going to solve for c. I would use this first equation because it has the least going on. So I have -6 equals a is -1, b is 8, and I'm solving for c. So -6 equals 7 plus c. I can subtract 7 from both sides, and I get that c equals -13. That means I can write my equation as y equals ax squared plus bx plus c. My a is -1, my b is 8, and my c is -13. So this is the formula for my quadratic graph. Remember, it is in your best interest to check your other points. So if you were to plug in, let's say, 4, 3 to this, it should work. If you plug in 3, 2, it should work. Even if you plug in 5, 2, it should work. Any point on this graph should now work in this equation. All right, that's the system of equations with 3 variables.